In this video, we're going to work through the SF package, which allows you to work with simple features in R. SF. Okay, so the SF package was released in CRAN in 2016. The SF package superseded the SP package. If you are familiar with working with spatial data in R, it implements a formal standard called simple feature to store and access simple spatial geometries. SF is, I think, even more intuitive than the SP package. It allows you to work with spatial data much more easily and more intuitively than packages in the past. So down here at the bottom, this is kind of going through some basics when it comes to spatial data, but within the SF package, you can work with point data, string data, or line segments, as well as polygons. These are all vector data. On the left, we just have more of the basic single point, single line, single polygon. It also allows you to work with multiple points, multiple strings, and multiple polygons, which you can imagine is a bit more what you would be working with when it comes to spatial data, especially when you're like transitioning from GIS to R. You're working with a shapefile with multiple shapes within it or geometries. So again, a bit of basics here, but SF objects are built using the following structures, and they build on top of each other. So an SFG object is just one of those simple geometries. It's one feature. It has one point or one line or one polygon. An SFC object here, the second point here, is a collection of SFG objects. So we have a collection of points, okay? And then finally, which I think is most similar to a shapefile within GIS, is what's called an SF object, and that's SFC, so a collection of geometries, but they have attributes. And so this is just an example how these points are colored by some sort of attribute. Okay. So there are different ways in which you can create SF objects. If you want to create those SFG objects, which are just that single point, single line string, or polygons, you will use these three functions here, st_point, st_line string, or st_polygon. And it's created from a numeric vector matrix or list of with coordinates. If you wish to combine these SFG objects, you can use the st_sfc, and this helps to combine feature geometries into a simple feature geometry list column. It holds the bounding box and the projection information. Okay, and you might have to set that as one of the arguments within an st_sfc. Finally, if you wish to add attributes, you can extend the SFC objects to the well-known data frame in R with a column that holds the simple feature collection, meaning the geometry. So you can use the function st_sf. Okay. I think this is more of a useful way of creating SF objects, and that's converting a data frame that contains latitude and longitude columns, as well as attributes, into an SF object. This creates a new object and leaves the original data frame untouched because it's no longer a data frame, it is now an SF object. And the function that you will be using here is the st_as_sf. That converts a data frame to an SF object. If you wish to set or retrieve the geometry column from an SF object, you're using the st_geometry function. And then finally, if you wish to set or retrieve the coordinate reference system of an SF object, you're using the stcrs. And there is a list of EPSG codes available for every single CRS or coordinate reference system that you're using, and you can find that online to provide the number in which you wish to be using. Okay, so that was how to create an SF object from scratch or from a data frame, but you can also read in shapefiles that you've created in GIS or manipulated in any way, and now you want to read it into R. The SF package relies on what is called the GDAL library, which is it's automatically linked, and that's what it uses when reading in. This is really just happening under the hood, but this is what's reading in the shapefile. And so, really, the most important thing on this slide is the function st_read. So just like we saw earlier with read_CSV, this is how you can read in shapefiles. And so you would, in the parentheses here, you would insert the path name to your shapefile and ensure that it has the extension .shp. You can assign this to a variable name called shapefile1. Okay, so just like in a previous video where I had kind of walked through ways in which you should inspect your data upon reading it into R, there are ways to do that with your SF objects. When you read in a shapefile using SF, it is read in as if it was a data frame, which is really amazing because you can start to work on the attribute data very easily. That being said, you can use some of the same functions that we saw earlier to start to inspect your SF object. But again, these functions only really operate on the attribute data. So again, to take a quick look at the data, you can use the names function, which returns a vector of all the column names, again, of your attribute data. Head tail returns the first and last parts of the SF object. str is short for structure, and it displays the internal structure of the SF object. So you'll have all of the column names, what kind of data type they are, a short list of what those columns entail. You will also see a column called geometry, which captures all of the spatial information related to each of those geometries within your SF object. Summary will still work in terms of producing the basic summary statistics of each of your variables. Again, remember this really operates best on continuous or numeric data. And then finally, unique, which helps you to look at the unique elements within the tabular or attribute data of your SF objects. Okay, so this should look familiar to some of the functions that we saw when working through dplyr, because they are. Again, SF package, the beauty of it is it works well with dplyr, with tidyr, because it's operating on the attribute data. So this is why I think working with shapefile, with spatial data within R is just so powerful when it comes to working with R. So again, you can start to manipulate SF objects just like data frames using dplyr. Remember, again, we are operating, I'm going to be emphasizing this throughout, we are operating on the attributes or the tabular data part of the SF objects. So we can start to select specific columns that we're interested in and get rid of others. It will always retain the geometry. We can filter the geometries where we only want certain rows that are from a given community or group. Again, it will keep throughout this, it will always keep the corresponding geometries. If we want to mutate and create a new attribute column or modify an existing one, we can use mutate. Group by and summarize helps us to group features by an attribute and start to aggregate other attributes, potentially merging geometry. So say we wanted the sum of the area of something, of a particular group, it would provide us with the area, and it would still keep the geometry of all of those points or all of those polygons. We can rename attribute columns, join. Functions work just the same here, left join, inner join, but remember, again, this is only on the attributes. Say for whatever reason you wish to drop the geometry, so drop the spatial component of an SF object, which ultimately converts it back to just a regular tabular data frame. You can use st_drop_geometry. Okay, so what we had just worked through on the previous slide was really, like I emphasized many times throughout that, was just on the tabular attribute data. There are functions within the SF package that allows you to do more topological manipulation. And that's what we have here on this slide. So the first kind of overarching topic is subsetting. So we can subset based on a buffer, based on a filter, based on intersections, just like we see in GIS. For the most part, you'll see these general functions with the prefix st_. So if you want a buffer, if you want to use a buffer, you would use st_buffer, and this computes a geometry, typically a polygon or a multi-polygon that represents all points whose distance from the original spatial object is less than or equal to the specified distance. So this, for example, says, say you have a collection of points and you want a buffer around each point that is 20 kilometers. Within these parentheses, you would indicate that you want your buffer. You would put in your shapefile name and then indicate the buffer size, which is the radius. The units here are important. The units that you provide in terms of what you want your buffer to be has to be consistent with your coordinate reference system. So if you're working in WGS84, that makes sure that your buffer, the units of your buffer is in degrees. Whereas if you have a projected coordinate reference system, then your units would be in meters. So that's something important to remember. And I've just pointed that out here. The units are determined by the coordinate reference system of your input SF object. Okay, so next we have st_filter, st_filter, and that helps to subset an SF object based on the spatial relationship with another SF object. And that differs from st_intersection, which performs an actual clipping operation and creates an SF object that cuts out the area of the buffer from the input SF object. So that depending on what output you wish to have, you would ensure that you're using the right function here. And these are very similar to what is in GIS. Okay, yet again, I've emphasized that the units are very important here. And when working with multiple input SF objects, you have to ensure that the coordinate reference systems are consistent. So that brings me to reprojecting SF objects. So you may have to change the coordinate reference systems of an SF object into a new one, especially when you're trying to say you want your first shapefile to be intersected with another one. They have to match in terms of their CRS. And so you can reproject one of the SF objects using st_transform. And so in those parentheses, you would insert the shapefile that you wish to transform or reproject, and then the associated CRS or coordinate reference system you wish to change it to, or transform it or reproject it to. Okay, so this is where the trickiest part is really finding the projection that you want and find the associated CRS code, in this case proj4 string, character string, I've provided a few examples here that might be of use, that uses the EPSG 3261, which is that UTM zone 16. This other one down here, EPSG 26716, which is the UTM zone 16 NAD 27. And these are most used for Belize in this case, in other countries, but this was made for Belize. Okay, so just like all the other packages that we just worked through, the SF package has a cheat sheet that is quite helpful. I just worked through a few of the topological manipulation functions that exist, but you can see here that there are plenty that are helpful. And again, I've provided the link here at the bottom. Okay, so from here, now we're going to start to work through how we can start to visualize simple features with ggplot. Again, this is why both the SF object and ggplot are just so amazing. They work together. They make visualizing spatial data so much easier. So this is a bit of a review in terms of just a generic ggplot, but I want to show you how we start to tweak little aspects of this, of the different layers, to now work with spatial data. The main thing that we're changing is the geoms we're working with. So instead of like say geom point or geom bar, we're now working with geom underscore SF. And this is indicating we're working with spatial data. Everything else works the same. You can indicate the fill, be a certain variable called area. You can still play with theme and all of that, but this is just relating to the geom, which is really the biggest thing we're tweaking here when it comes to working with spatial data. So a bit more about visualizing SF objects. Here, again, if you remember in the AES, we're identifying X and Y, which in this case would be lat and long. We don't need to do that really, because when it comes to geom SF, you don't really need to specify the geometry because you have a column in your SF object called geometry and it's smart enough to know. What I'm saying in this box here is unless you have multiple geometry columns which in that case, that's a bit worrisome. But if you do, that is when you would identify geometry equals, and then you would indicate the geometry column. But for the most part, you should only be having one geometry column within your SF object. So that being said, in your AES, you would really just be indicating any sort of color that you want to accentuate across some sort of variable like site here. Okay, so again, I mentioned in the past when it comes to ggplot, you're not really playing too much with the coordinate reference or the coordinate system, but here you are because you're working with spatial data. So what function you would use is coord underscore SF, and this allows you to indicate the X, basically the bounding box. So you would say X lim, and then you would indicate the min and max longitude of your map, and same with Y lim. For the most part, you don't need to indicate the CRS unless you wish to be mapping in different CRs than what your data is, but ggplot is smart enough to know, okay, we're working in WGS. That is the coordinate reference system we're working in. This expand equals true or false. That is just an argument saying sometimes what happens is if you say expand equals true, sometimes the map will kind of bump out a little further than your X and Y limbs just to create some sort of plot margin. If you don't wish for that to happen, you would just say expand equals false here. Okay, and then we did see geom label and geom text earlier, but this is now just working with, again, spatial data. So there's great examples here. Say, for example, you have these sites, but you wish to label them. You can use geom SF label, geom SF text. The only difference here is label. The text has this little white bounding box here, whereas text is just literally the text in its rawest form. And in either one, you're indicating what you wish each label or text to say. And if you're using geom SF label, you would say label equals and then provide the variable name that you wish to be used to indicate or correspond to the names of each site, and so on with geom text as well. Okay, and so this last slide is really just showing you that really everything else stays the same. We have scale X continuous. You can indicate the breaks within your map that you wish to show, like the resolution. Theme classic, theme minimal. Labels if you wish to indicate what is lat and long, and theme in terms of text size, color, what have you. Okay, so the last thing when it comes to creating a map within R is adding the scale and the north arrow. And so these two are actually included using another additional package called ggspatial, and it makes it quite easy to use. In each, really this text, these two code chunks, I think it would be best to just copy this and put it into your own code. But it's actually quite helpful. The first argument in both are location, and it has some predefined areas. So this would be bottom left. There's other inputs or other options you can include, bottom right, top left, top right. And that's just a generic area based, doesn't matter what where you are in the world in terms of what you're mapping. This always knows within your figure, within your map, we're going to put the scale bottom left. With hint, height just allows you to play with the proportion of the plot area that will be the scale bar, while height is actual an actual measurement. And you can use the function unit, provide a measurement and the units in which you wish to use. Pad X and pad Y. So say you use one of these generic locations at the top, you can then start to pad it to the X, across the X axis or the Y axis a bit using the pad X and Y. And the same goes for the north arrow. The only difference here is you have this added argument of style. And so there are a few different styles of north arrows that you can use. This happens to, they're generic, they're within this package. This one happens to be called North Arrow Fancy Orienteering, but there are other styles of North Arrows here. I don't provide the actual link written out here, so you can, it's really just easy to Google. If you just Google ggspatial North Arrow options, it should pop up. Okay, so here as well, there are a few more resources in terms of base maps and additional tutorials that walk through how best to use the SF package to work with shapefiles, manipulate shapefiles, and then finally visualize using ggplot.